In this lecture, we are going to analyze depletion type MOSFET. Considering N-channel MOSFET. To operate depletion type MOSFET under depletion mode, drain is positively biased with respect to the source and gate is negatively biased with respect to source. Consider the case when gate to source voltage is kept 0. In this case, the drain current is maximum, which is denoted by IDSS, referring drain to source saturation current. Now consider the second case when gate to source voltage is applied. In this case, the drain current reduces as gate voltage is provided with negative voltage. When gate is given sufficient negative voltage, large number of positive charges will be accumulated on the inversion layer, and due to total recombination, no negative charges will be reaching the drain and the drain current will reduce to 0. Now we will analyze how N-channel depletion MOSFET is operated under enhancement mode. In enhancement mode, both drain and gate are positively biased with respect to source. When gate to source voltage is kept 0, drain current in this condition will be the minimum drain current. But when gate is applied with a positive voltage, negative charges are created and more negative charges will be reaching to the drain, thus increasing drain current, which becomes greater than IDSS. This is the ideal transfer characteristics graph of N-channel MOSFET. Current at 0 gate to source voltage can be denoted by IDSS, and if we operate this MOSFET with negative gate to source voltages, then MOSFET is said to be operated under depletion mode, whereas if the MOSFET is operated with positive gate to source voltages, then MOSFET is said to be operated in enhancement mode. It is quite clear from the graph how these modes are named, as when the negative voltage is applied, the resulting current decreases compared to current at 0 gate to source voltage, whereas in enhancement mode it increases. The gate to source voltage when the drain current becomes 0 is a very important parameter, which is here denoted by Vp, referring pinch off voltage. We have seen earlier also that ideally there is no current when gate to source voltage is smaller than threshold voltage. So the value of pinch off voltage is nothing but the threshold voltage. And as we know already, for N-channel depletion type MOSFET, threshold voltage will be negative, which can also be easily verified from the shown graph. Similarly, we can draw drain characteristics graph of N-channel MOSFET at different gate to source voltages. In this graph also, we can represent different regions like cutoff region, linear region, and saturation region. Here also we have only a single point, which is origin, which can be said to be operated in cutoff region. I am writing symmetric just to signify that we have considered only positive drain to source voltages. Unlike enhancement type MOSFET, there is no channel length modulation in depletion type MOSFET. It is safe to assume saturation current becomes nearly constant in depletion type MOSFET. Drain current in depletion type MOSFET is equal to drain to source saturation current within bracket 1 minus gate to source voltage divided by pinch off voltage raised to the power 2.